Section 9.1, Part 2, Operations on Radicals. Today we're going to look at some radical expressions that are not simplified, but can't be simplified using the techniques we talked about in the previous lesson. For example, the first one is the square root of 10 over the square root of 3. Now this is not simplified because I have a radical in my denominator. In order to deal with this, however, I cannot just rely on making this the square root of 10 thirds. Well, that's true. That doesn't reduce at all, and it still leaves me with the problem of having a square root that contains a fraction, and that's no good. So, while that's true, it's not helpful. So let's get rid of that. So instead, here's what I do. I multiply this fraction by a very fancy-looking 1. Now, it's fancy because it's not going to look like 1, but it's going to be equivalent to 1. I'm going to take the radical that I start with in the denominator, square root of 3, and I'm going to multiply that in the denominator and up in the numerator. Now clearly, this fraction equals 1 because it's the square root of 3 over the square root of 3. That means I'm multiplying my original number by 1, and I'm not changing it. I will just change the way that it looks. Now when I multiply across. I do the square root of 10 times the square root of 3. Because it's a 10 and a 3 both inside a radical, that's going to become the square root of 30. My denominator is square root of 3 times the square root of 3, which is going to be the square root of 9. And now what I see is that I can simplify my denominator. And it's just going to become the square root of 30 over 3. Now that right there is completely simplified. 30 has no perfect square factors other than 1, and I no longer have a radical in my denominator, so I'm all set. I can do the same exact thing if I have a radical that contains a value with a variable in the denominator. So here I see 7 over the square root of 2x. I'm going to multiply by that fancy 1, square root of 2x over the square root of 2x, and I multiply. Now when I multiply here, I have to multiply the 7 times the square root of 2x. The 7 is outside the radical. The 2x is inside the radical. I can't combine them any closer than that. I don't get 14x either inside or outside the radical. It just stays like that. Inside the radical, I'm going to multiply the 2 times 2 to get 4, and the x times x to get x squared. Now I want to see if I can simplify that denominator. My numerator stays the same, 7 square root of 2x. And the square root of 4 is 2. The square root of x squared, again, as I mentioned before, I'm always looking for pairs, so I'm just going to take out an x, and I have nothing left inside a radical, so I get my final answer, 7 square root of 2x over 2x. You'll notice that in both of these cases, my final denominator ends up being my original denominator without the radical. That will almost always be the case unless we can end up reducing even further. All right, let's see 2 more examples. So here are a couple more. First we have the square root of 2y squared over 3. Right now it's a fraction inside of a radical, so I'm going to rewrite that as the square root of 2y squared over the square root of 3. Now, the square root of 2y squared, I can't simplify the square root of 2, but I can simplify the y squared. The square root of y squared is just y square root of 2 over the square root of 3. Now I have to use my trick with the fancy 1. I don't want to have that square root of 3 in the denominator, so I multiply by the square root of 3 over the square root of 3, which is going to equal y square root of 2 times 3 is 6, over the square root of 3 times 3 is 9, which means my final answer is y square root 6, and you could put the square root of 6 first if you want, over 3. And that's my final answer there. All right. And for the next one, I've got the square root of 32, which actually I can try to simplify that a little bit first before I go anywhere else. I've got the square root of 32, which is the square root of 16 times the square root of 2. I chose 16 because that's a perfect square. So I can take the square root of that and get 4 square root of 2. Now, what I can do with that, rather than multiplying the numerator and denominator by the square root of 32, all I need to include is the square root of 2. And that'll work out just fine for me. My numerator is 5 square root of 2. My denominator becomes 4 square root of 4. That's something we got to keep in mind there. The square root of 2 times the square root of 2, I can multiply those two numbers because they're both in radicals. That's going to give me 5 square root of 2 over 4 times 2. That's what the square root of 4 is. And when I multiply out my denominator, I get 5 square root of 2 over 8. And that's my final answer. All right, hope these examples make sense. All right, so one thing we can do is we can add and subtract radical expressions. And what I've done here is I've highlighted the fact that a number next to a radical indicates multiplication. So when I say 5 square root of 11, I mean 5 times square root of 11. Or 5 square root of 7 is 5 times the square root of 7. We want to treat these like they're like terms, x's and y's almost, with variables, and combine them by combining the coefficients. So I notice here that I have 5 square root of 7 minus 8 square root of 7. So when I combine those, I really just combine the 5 and the minus 8. 5 minus 8 is negative 3, and then I attach the radical on it. I don't need to write the times. That's in the original example to emphasize what the relationship is. But there I have it, negative 3 square root of 7. Just like if it was 5x minus 8x, I'd have negative 3x. Next, I want to combine the plus 11 and the plus 5 times square root of 11. I'm sorry, I said plus 11 before I meant square root 11. That's really as if I have an invisible 1 in there. So I'm going to add the 1 and the 5 to give me 6 square root 11. And that's actually all that I can do. This would be like having a final answer of negative 3x plus 6y. Because the radicals are different, I can't combine them by addition. And that's actually simplified. That's all that I need. All right, so let's take a look at another example, which maybe at first looks like there's nothing else we can do. Here I have 10 square root of 5 plus the square root of 20. Seems like there's nothing I can do here because the square root of 5 and the square root of 20 are different radicals. However, if I keep the 10 square root of 5, I am able to take that square root of 20 and break it down. The square root of 20, remember, is the square root of 4 times the square root of 5. 20 has the factors of 4 and 5, and 4 is a perfect square. That means I'm dealing with 10 square root of 5 plus 2 square root of 5. And now they're like terms, so I can combine them. Add the 10 and the 2, and I get 12 square root 5. And that is going to be my final answer. It has to do with breaking down what looks like are different different radicals and ending up with like terms that can be combined. All right, hope this helps. All right, now the last thing that I want to look at is multiplying radical expressions. So here I have the square root of 6 times 5 square root of 3. When you're multiplying, we're not using a distributive property here because we don't have any addition or subtraction. And so when we multiply, we only want to multiply the things that are inside radicals and the things that are outside radicals. With my first factor here, square root of 6, I have nothing outside the radicals, so I treat it almost like a 1. And I can do 1 times 5, which gives me 5. Then I multiply what's inside the radicals. That's 6 times 3, which is 18. So the initial answer for my product is 5 square root of 18. I'm not done yet, though. I need to make sure this is totally simplified. The square root of 18 can be broken down into the square root of 9 times the square root of 2. Now remember that 5 square root of 18 means 5 times the square root of 18. That means 5 square root of 9 square root of 2 means I have 3 things being multiplied. So I can rewrite this as 5 times, and the square root of 9 is 3 times the square root of 2, which now allows me to take 5 times 3 and get 15 square root of 2. And that's going to be my final answer. That's a simplified version of my original problem. All right, let's see another example here. Here you see that I have square root of 5 times the square root of 3 minus the square root of 75. This is outside of parentheses. So what I need to do is I need to use the distributive property because I have a subtraction on the inside. Now I have no coefficients, so it's actually going to be pretty straightforward. I multiply the 5 times the 3 and get 15. And then I'm going to do 5 times 75, which is 375. Now, at first it seems like I can't combine these any further. However, I can break up the square root of 375 into 25 and 15. 25 is a perfect square, so that's why I've picked that. That gives me the square root of 15 minus 5 square root of 15, and now they're like terms. I have 1 square root of 15 minus 5 square roots of 15 gives me negative 4 square root of 15. And that is my final answer. That's what I have there. All right, one last one to look at here. 2 square root of 5 minus 4 squared. Common mistake is just to square everything and get your answer. Can't do that. When we say something is squared, it means it's multiplying by itself. That's 2 square root of 5 minus 4 times 2 square root of 5 minus 4. Now, lots of different ways you can do this. You can use FOIL, distributive property, crab claw, Punnett square. Let's use the Punnett square just for the practice. All right, so up on top, I'm going to have 2 square root of 5 and negative 4. And on the side, 2 square root of 5 and negative 4. Now, when I multiply in the top left, that's 2 times 2 is 4, and 5 times 5 is 25 inside that radical. Top right, negative 4 is multiplying just the 2, so that's negative 8 rad 5. Same thing in the bottom left, negative 8 rad 5. In the bottom right, it's a negative times a negative, so I'm going to get a positive 16. So that's what I have. Now I just go ahead and combine these. Now 4 squared root of 25 ends up being 4 times 5. These two terms in the middle are like terms, so I'm going to combine them to get negative 16 rad 5. And then I have a plus 16 at the end. So you can see this is going to be 20 minus 16 rad 5 plus 16. Combine the constants on the outside. That's 36 minus 16 rad 5. And that's actually it. That's my final answer. So there are a bunch of examples of how you multiply and simplify expressions with radicals.